Hello everyone, welcome to the ETAP eSCADA solution presentation. My name is Hugo Castro. I am the Senior Vice President of Project Execution and Delivery at ETAP. We are excited to present our electrical SCADA or eSCADA solution and how its features such as situational intelligence can provide a comprehensive overview of your power system in real time. We will be covering topics including customer challenges, ETAP eSCADA value proposition, and we will also dive into the benefits and features. Let's get started. In today's electrical industry, the digital transformation journey brings new challenges as we move towards innovative digital products. First, SCADA systems are now capable of more than ever to consolidate and monitor all real-time data that affects any portion of the operation. In a parallel way, new electrical assets aim to provide as much data as the device can collect. However, newer systems have the tendency to create new branches and silos of information, resulting in a deviation from a single source of truth in operation. New industry challenges also bring the requirement of adapting to rapid changes in operation. Today's industry requires systems to adapt rapidly to new changes in operation, all the while keeping critical operations running. Engineers are now required to identify faster and with better accuracy all areas of opportunity within the existing operation and plan for future every day. As more data becomes available, there is also the requirement for a full understanding of the operation. Electrical systems are now expected to become smarter and process intelligently all real-time data, and identify areas of risk in operation and troubleshoot faster current operation troubled areas. Finally, electrical systems are required to make intelligent decisions and better inform their personnel. Operations need to have informed decisions about the possible contingencies and be notified in the case of an operation procedure or action may not be safe to execute. In order to solve these challenges, the ETAP eSCADA solution is designed to meet these challenges. This solution leverages the ETAP digital twin model to monitor and simulate. It also provides readily available HMIs using the existing ETAP digital twin model to generate powerful operator views and dashboards. It supports system operators to help them make important decisions in a daily plan operations, such as starting loads, shutting down operations, load transfers, and more. The eSCADA solution also provides multiple user interfaces for operators, engineers, and managers so they can easily visualize a summary of the electrical operation and its health status. This solution also provides a tool to predict and analyze the electrical system response before an operation is executed. When an operator needs to perform changes in the operation and maintenance, such as a breaker operation, motor starts, generator operations, load transfers, and more, they can simulate and validate the response of the electrical network and understand risks and avoid unforeseen conditions such as faults with voltage, frequency, protection system operations, and power quality issues. At this point, you are probably asking yourself, why choose ETAP SCADA? The primary features you will see in this system include model validation and enhanced system visibility, validate before operate analysis, intelligent electrical SCADA tools, situational intelligence, enhanced electrical HMI interface, secure and scalable solution with an open architecture. Now I will introduce some of the examples of the value that ETAP eSCADA brings the electrical systems operation. Model validation and enhanced system visibility tools transform your existing digital twin model into a reliable eSCADA solution. The model validation tool uses an engineering perspective to validate the digital twin against live power and metering from assets in the field such as relays, RTUs, power meters. The enhanced visibility increases the visualization of the power flow metering in areas where there is no instrumentation available. Validate before operate analysis allows engineers and operators to run what-if scenarios using ETAP power simulation modules and understand possible risks with current operations or events in the past. Powerful monitoring is complemented with powerful SCADA tools. These tools, such as alarms, events, trending, and more, provide engineers and operators with full visualization of the state of the electrical operation. Smart tools such as Situational Intelligence continuously evaluate the systems against predefined contingencies or major events and notify operators in the case where an operator procedure or action may result in an unstable or undesired conditions. ETAP eSCADA solution is a secure and scalable solution with an open architecture. Its secure environment allows system administrators to limit users to specific features and actions. Its scalability allows network architects to deploy simple systems and, in the future, add more functionalities and implement an enterprise architecture. Best of all, its open architecture allows ETAP to operate in a hardware-independent environment and be able to communicate to electrical assets such as relays, power meters, RTUs, PLCs without the need of additional hardware. Now let's take a look into some of these features and key benefits. First, let's look at the model validation and enhanced system visibility. ETAP provides quick and easy tools to enhance an existing digital twin model to interface with existing electrical assets that can provide power measurements such as current, voltage, real and reactive power, and many more. Through this tool, users generate a library of components with typical measurements for a component and easily create and maintain a SCADA database without the need of advanced programming. Next, the ETAP State Estimation Engine provides tools for model validation and enhanced visibility. The State Estimation Validation tool compares all the discrepancies between the existing digital twin model and the electrical asset measurement. This comparison is done from an electrical perspective, bringing to light issues that the digital twin model may not be up to date to reflect the actual operation, or where the instrumentation may not be calibrated correctly to represent the correct power readings. Note that any of these validations are not easily identifiable with a traditional SCADA. The state estimation enhances visibility features, displays additional power flow measurements in areas where no instrumentation is available. This is particularly useful as for many electrical operations, it may not be feasible or cost-effective to add power monitoring instrumentation to all their assets. Leveraging the digital twin and available power monitoring data, the state estimation feature can make visible the power flow across the model. State estimation alarms notify engineers and operators of potential risks with the operation. By understanding the digital twin model and the live measurements, the state estimation feature is capable of notifying operators of alarms conditions due to overload or operating bus voltage. Next, we will look at the feature benefits from Validate Before Operate. The Validate Before Operate feature provides us with powerful insights for questions in operation, planning, and switching in real-time or historical conditions. This feature allows to update the simulation topology of an ETAP model using current real-time state or historical snapshot. This action, while it may look simple, saves planning and operation engineers hundreds of hours or days in updating their offline electrical models to reflect a single operating condition. While in ETAP real-time, it just takes a single click. Using Validate Before Operate, you can utilize any of the full spectrum of analysis modules in ETAP, such as load flow, short circuit, protected device coordination, transient stability, motor acceleration, harmonics, and more to determine the system response against different events. Let's take a look at a few examples of these events in action. Using ETAP load flow, you can evaluate scenarios such as changing the topology and simulating bringing down a transformer. From this scenario, we can observe as a transformer is being brought offline. When we open the required breakers, we notice that this possible action will create an overload condition. Using ETAP load flow, I can also evaluate for planning purposes the effect of increasing the amount of load in a component. Before we run the load flow analysis, we can update the component with the planned increase in load. Protection and coordination can also be evaluated using transient stability, where I can simulate the effects of opening a tie breaker for maintenance or evaluate how it will impact the system. In this case, we can set up a condition where after 100 milliseconds, the circuit breaker is open. Once we run the scenario, we can see that after a few seconds, the bus will be tripped because of an overcurrent relay detecting the fault. Finally, we can evaluate the effects of running maintenance procedures using Etap switching sequence. Using Etap, I can build the maintenance procedure, then analyze the effects of running such procedures using real-time conditions, and determine if executing the procedure can cause or adverse conditions in the electrical system. Next, we can look at some of the additional benefits of the intelligent SCADA tools. The Etap Alarm Manager allows the operator to look at different types of alarms, including SCADA alarms and analytical alarms. SCADA alarms are caused by deviations from real-time measurements to an undesired range of operating state. Analytical alarms are generated by Etap because of detecting deviations in the operating loading or bus voltage in the digital twin model using real-time conditions. The Etap Alarm Manager provides full control and management of alarms, including actions such as mute, silence, acknowledge, and more. In addition, the Etap Alarm Manager can send notifications via email to personnel. This is particularly useful for critical events with high severity that require operations personnel to take immediate actions. The Etap Event Viewer is also powerful for event management. This tool provides full visualization of past events recorded, such as alarms, warnings, measurement notifications, changes in operating state, as well as issues in the operating state of the Etap SCADA system, such as loss of communication, server failures, etc. The trending feature allows us to visualize trends of different historical data from measurements recorded from the field. Users may further customize trends as visualization by changing the plot range, combining trends, visualize across hairs, just to mention a few. The information plotted can be portable to different formats such as CSV or Excel for further analysis. Operator Notes allows the operator to create notes regarding components directly in the one-line diagram or HMI in the system. This is a powerful tool that can be used to improve communication between operators and engineers. It allows them to share important knowledge such as equipment service states, including maintenance. These actions can be paired with temporary inhibitions such as alarms, control, or scan inhibits to protect the operation for a specific period. Finally, let's take a look at the Etap Situational Intelligence feature. This feature is a critical app for control room operators for secure and efficient power system operation by identifying potential unsafe actions and conditions. First, users identify potential problems and contingencies that require the operators to be notified in case of a potential unsafe condition is detected. Leveraging the intelligence of the Etap predictive analysis tools, engineers can first identify and create simulation scenarios for all conditions that will require to be continuously evaluated, as they may cause a significant impact to the operation. Examples of such actions can include isolating a transformer, where the operating load may cause an overload in the system. Another example is the start of a large motor that can cause instability on the system due to required power during the startup. These scenarios are then visualized by the operators and observed if there are any potential unsafe conditions for specific events. This simple simulation can provide a short summary to the operator if proceeding with an action may be safe or if alerts are detected, and it may require an alternative course of action. This continuous power analysis in real time provides a better and simpler understanding of the network. As the operator interface, Etap provides the capability of generating personalized dashboards. The Etap HMI provides user-friendly interface for operators to visualize and monitor the electrical system. Using the Etap HMI Designer application, users can import the digital twin model from the Etap power simulation software. Then from there, customized views can be created and enhanced with key visualization components such as gauges, digital state indicators, and trends. From the Etap HMI viewer, we can visualize, simplify graphics with key information to operators and generate customized navigation bars for easiness of navigation. Note that we can also create key summary views to further observe critical asset information. Through these HMI dashboards, we can create equipment detail information where we can display critical asset real-time information, including alarms or a state of operation. All this by using the existing digital twin model and existing SCADA database, eliminating the need for multiple software and automation databases, and decentralizing them in a single solution. In conclusion, ETAP eSCADA is an effective decision-making solution for power system operations. Model validation and true system visibility tools improve the digital twin by bringing the model to reflect its true operating condition. Validate before operate analysis provides valuable predictive simulation to determine the effects of changes in the operating conditions of the digital twin due to planning, maintenance, and changes in the operation. Intelligent electrical SCADA tools complement the real-time operation of the digital twin by providing further visualization via alarms, events, and trends. Additionally, power tools like operator notes improve communication across operations staff in regard to the operating state of assets and temporary actions. Situational intelligence is a critical tool for control room operators for secure and efficient power system operator by continuously evaluating the stability of the power system using predictive simulation and identifying potential problems under current conditions before operator actions. Thank you.